Welcome back to this tutorial series. In this episode, we're going to create a goal out of Quixel Bridge assets that allows our player to score when the ball passes through it. I'm also going to introduce you to creating your first function that we can call on another blueprint. There's plenty of work to do, so let's get to it. To start, let's head over to Quixel Bridge. You can find this by navigating to the Get Content button at the top of the editor. Quixel Bridge is Unreal's inbuilt plugin that has an extensive library of high quality assets ready for you to download and incorporate into your projects. For this tutorial, let's just search for Japanese statue. In the search results, we want to grab the left and the right versions of this statue. Once selected, make sure to select the quality of the asset from the drop-down list. For now, I'm going to select the nanite versions of these statues. Once they've downloaded, make sure to click on Add to import the assets into your project. Once your assets have been imported, you'll notice that they've been placed into a new Megascans folder in your content browser. We can now head over to our Blueprints folder, right-click into the content browser, and create a new blueprint class. In the new window, we'll be presented with a bunch of blueprints that we can create for the goal. We're going to want to select an actor as our base template. An actor is just an object that you can place within your scene. Unity users will recognize this as a game object. Once created, let's rename our blueprint to BP_goal. When we open up our blueprint, let's look for the statues we've just downloaded in the content browser. We can then drag these assets into the Components tab so we can see them in the viewport. Once placed, we can then set the X transform values in the Details tab. We can then set these values to 100 for the right statue and -100 for the left. As you can see, the left statue is at the incorrect angle. We can quickly sort this by changing its Z rotation in the Details tab to 90. To register our ball scoring a goal, we need something for our ball to trigger. Just like our ball blueprint, we can add in another box collider by clicking on Add and searching for Box Collider. We now need to reposition this to fit our goal. Make sure the collider is centered, and you can change the scale on the X value to 3. We can then do some manual repositioning to make sure that it fits and is level with our goal. For now, let's compile and save this blueprint so we can place it into our scene. We can then drag this out of our content browser and into our viewport. Using the keyboard shortcut E, we can rotate this object to our desired rotation. We can then press W to reposition our goal again. Once in position, we can then change the scale of this object by setting the scale values in the Details tab to 4 on the X, Y, and Z. Currently, our statues don't have any collisions, so let's fix that. If we head to our content browser again, we can open up one of the statue's blueprints. As this is a complex mesh with lots of detail, we're going to want a collider that is more than a simple box or sphere. In the bottom right, we have the Convex Decomposition tab. This can apply a more fitting collider for our statue if we click on Apply. We can then save this and repeat the process for the other statue. Now that we have our colliders set up, we can head back to the goal blueprint to finish the logic for the goal. Similar to our ball, let's create an event for when the ball touches the collider. By selecting the collider and heading down the Details tab, we can select the On Component Begin overlap. When in the event graph, we we can delete the starting nodes that it provides, as we won't need them. In the Variables tab, we want to create a new variable which will keep count of the player's score. If we press the plus icon, we can create a new variable and rename it to score. We can then set this variable to an integer to store a number by clicking on the drop-down menu and selecting it. Now, if we look at the node we created, there's a pin for another actor that we can reference when it touches the collider. We can then drag out this pin and search for the ball component that is in the current scene by selecting the Cast To option. Currently, we want to increment the number whenever the ball touches the collider. We can do this by adding in an increment float node by dragging out our execution pin and searching for increment. We can now drag out a reference to the score variable that we created earlier, and then select Get. We can then feed this into the increment node. This code will now currently grab the score variable and increment it, but that's not enough. We now need to grab another reference to our score, but this time select Set. We can now connect the execution and int pins to complete this increment. This will now take the score variable, increment it, and set it back to the variable. Now, to test that this is working, we can right-click in the graph and debug this using the node printString. Unity users should recognize this node as debug.log. If you look at the color of the variable pins that are in these two nodes, you'll notice that they are not the same color. We need a way to convert this integer, which is a number, to a string output, which is text. We can simply do this by right-clicking in the graph and searching for int to string. We can then feed this into our current code by connecting the pins together, and then connect the execution pins. If we compile and save this, we can head back into the main editor to check that this is working. If you direct your attention to the top left corner of the viewport window when we score a goal, a debug message should pop up stating that you've scored a point. Awesome! Now, let's head back into the ball blueprint. If you remember in our last tutorial, we created some code that would reset the ball's position when leaving the box collider. We can reuse this code for our goal in the form of a function. A function is a single node that contains multiple code components within it. If you're a Unity user, you might recognize this as a C# method that we can call at any point to organize and shorten parts of code. To create a function, click on the plus icon on the Functions tab. Then, let's rename this to Reset Ball Pos. Now that we've created our function, let's go back to our event graph. And then, navigate to the code that resets the ball. From here, we want to highlight the three nodes and its references. Make sure to not include the delay. We can then right-click and cut this code out, and head back into the function to paste it in. We can then connect the execution pin from our Reset Ball Pos function into the start of this code block. Now, let's compile and save this and head back into the event graph. Now that we've created our function, we can reference it by dragging it into the graph and connecting it back up to the delay node as normal. Make sure you compile and save, and then head back over to the goal blueprint. Now, we need a way to reference this function that's on another blueprint into this blueprint to use. We can start by dragging out the execution pin from our printString and searching for Get Actor of Class. We can then select the actor that we want to reference in the drop-down tab found in the new node by searching for ball. Now that we have our ball actor reference, we can call the reset function from it by dragging out the execution pin and searching for reset ball pos. We can then connect the target pins. If we then compile and save this and head back into the editor, we can test that this resets the ball's position when scoring a goal. Awesome! Now, there's just one more thing we need to do. Currently, our code still tries to reset the ball when reset by the goal, so let's fix that. Let's select our box collider and head into the Details tab and add a component begin overlap. From here, we can copy the code from our previous statement. We can then feed this into our node the same way we did before. Next, let's create a boolean to store whether the ball has been reset. We can then drag this into our event graph and click Set. We can then connect the execution pins and check the ball reset to true. Next, let's drag in another reference to our ball reset boolean and click Set. We can then double click on the execution connection and delete the pin to break the connection, and then feed in our set node. We can then do the same with our delay node and add in another branch node. Next, we can grab another reference to our ball reset and this time select get. We can then feed this into our if statement and then connect the false pin to our firework. Now that our code's finished, we can create comments by highlighting our code segments, right-clicking and selecting Create Comment. We can then call this Reset Ball after 5 seconds. We can then do the same with our other code and call it Check if the ball's reset. Now, let's compile and save and head back into the editor. If we press play, we can check if this is still working. Awesome! For now, that's all we have time for in this episode, so make sure to stick around for the next one as we create a goalkeeper and create a win condition for our game.